Welcome everyone to this new episode of our vlog series. I am Alessandro Tacconelli, PhD candidate of the Center for Law and Economics here at ETH Zurich. With the rise of AI, LLMs are increasingly used to perform tasks traditionally performed by humans, including legal interpretation. The prospect of using those models as AI judges raises interesting possibilities. They can provide consistent, fast, and ostensibly unbiased answers to legal questions. But can those models be trusted? Can we rely on their outputs? And do those outputs hold under the scrutiny of empirical testing? I'm very happy to have here with me today Professor Jonathan Choi, Professor of Law at USC. His research focuses on law and artificial intelligence, so applying natural language processing methods to try to answer legal questions, but also tax law and statutory interpretation. Today, we will be talking about his research article, Off-the-Shelf Large Language Models Are Unreliable Judges. Welcome, John.
Great, thank you for having me.
So, John, before we dive into the core of our discussion, why don't you give us a brief summary of the background of your article?
Absolutely. So, large language models are increasingly being used by real judges to decide or at least inform their decisions in real cases. Judges will ask large language models essentially the core legal question in a case and rely on the large language model's response in rendering a decision. Now, this has been recommended by some judges as well as by some scholars, but there hasn't been a lot of empirical research suggesting the reliability of these kinds of judgments. And in my article, I identify 3 different reasons why they might be unreliable. One is that depending on how the question is phrased to the LLM and how the LLM's response is processed, you can get radically different results. So based on plausible alternative rephrasings of the same prompt, you can get a different answer from the LLM. A second problem is that asking the same question of different LLMs can also give you different answers, and the correlation between the answers different LLMs give is very low. And then a third problem is that one of the main reasons judges use LLMs is to try and access empirical information about how language is used. But it turns out that the way that these models are trained draws their responses away from just reflecting ordinary language usage. And so judges might not be getting the kind of empirical linguistic information they believe they're getting from the large language model. So all of these things suggest that large language models are not as consistent, reliable as judges expect. And it also means that if judges or lawyers want to cherry pick outputs from large language models, they might be able to do so, which again undermines the validity of LLM results.
Thanks, John. Very interesting. So, as you said, the starting point of your research is the growing trend of judges turning to tools like ChatGPT for decision-making process. Now, at the first glance, this might even sound amusing, right? To imagine judges closed in their chambers, facing complex legal dilemmas and just asking AI for help. But is this really happening? Can you give us some real-life examples of cases of judges that relied on AI in the rulings?
Absolutely. So it's been done in a number of different countries: India, Peru, Colombia, Mexico, Brazil. I'll give you an example from Colombia. So there was a judge there who was deciding whether or not a health insurer needed to cover the entirety of the treatment for an autistic child. And the Colombian judge just asked ChatGPT in Spanish, so this is a translation, is an autistic child exempt from co-payments to a health insurer for treatment? So that's the key question in the case. And the judge just copied and pasted ChatGPT's response, and that response, copied and pasted, was more than 25% of the opinion that was ultimately published. So that suggests heavy reliance, both in the reasoning by the model and in the answer given by the model. The judge very heavily leaned on what ChatGPT said. And we see similar examples in those other countries that I mentioned. And there have also been moves in the UK and in the United States to do the same kind of thing. Now, there hasn't been a lot of scrutiny over whether this is a good idea so far, and that's what my paper tries to bring to the table. In some of these cases, there's been pushback suggesting that the judges were incautious in implementing ChatGPT's recommendations in this way.
Thanks, John. So, as you can imagine, our viewers may have different levels of familiarity with LLMs and how they work. So maybe can you give us a brief primer on LLMs? At least those key aspects that may help us understand better your research.
Absolutely. So the short description is that large language models are trained in two broad steps, which we call pre-training and post-training. In pre-training, a model is given a huge corpus of text, the entire internet, and TV and movie transcripts, and books, magazines, all sorts of text, anything that people can find. And based on this text, the model learns how to predict the next word given a sentence, paragraph, whatever. So if you see the sentence, the cat in the blank, the model predicts, okay, it's probably the cat in the hat, or it's the cat in the yard, something like that. And it learns how to reflect the empirical realities of how words are used and to reflect what words would commonly be found next. That's not the end of the story, though, because if you train on the entire internet, it turns out that you get a lot of racist, a lot of sexist, a lot of offensive or problematic content reflected in the large language model. And therefore, model designers generally also put them through what we call post-training. So in addition to just reflecting the text as it is out there in the world, large language models are tuned in order to give helpful, non-offensive responses and to behave in particular ways. So for example, to behave like chatbots. This process takes model outputs away from empirical predictions of next words. And it also means that if you're trying to use large language models to reflect linguistic reality, they might not do so. They might, but they might not, because it could be that in making the models less offensive, you also make them less likely to say what the real next word would have been in a particular sentence.
Thanks, John. So, as you just mentioned, your research tackles some fundamental questions, including how sensitive LLMs are to prompts, output processing methods, and model training choices, but also whether LLM can assess ordinary meaning in the way some advocates of AI judging hope they can. And in order to answer those questions, you ran a series of experiments. But then can you give us a summary of those experiments and how do your results look like?
Absolutely. So there were 3 separate experiments. The first experiment asked how model outputs differ based on the prompt given to the model. So I took a given set of facts and I generated 10,000 variations using a first large language model. I generated 10,000 variations of a simple question based on those facts, much like the Colombian judge boiled down the facts of a case into a single legal question that could be asked of an LLM. And so of these 10,000 variations on a simple question, how did the large language model's outputs differ in responding to that question? And I found that there was a huge range, that sometimes the model would say it's completely confident the answer is X, and sometimes it would say it's completely confident the answer is not X, and everything in between. So the distribution of the feedback given by the large language model was non-normal, so it tended to be bimodal. It was overconfident at both extremes. And in addition, the range was extremely broad. Basically, the 95% confidence interval went all the way from extremely confident on one side to extremely confident on the other side. So that suggests a lot of variation in the large language model's judgments in any particular case. What does this mean? It means that if a large language model were used, it could be used selectively. You could find the right prompt to give the right answer that you want if you're a motivated judge or if you're a litigant trying to argue for the use of large language models. And it also means that depending on just randomness in how a judge phrases the question, you can get a totally different result. The results are inconsistent. So that's one finding. The second experiment was whether if you ask the exact same question of different large language models, so now we're varying the model, not the question, whether you get different results. And I find that you do get extremely different results, that there's almost no correlation between the answers given by different large language models. Why is this? Well, maybe because of the training choices in the database that was used to pre-train the model, training choices in the architecture of the model, training choices in post-training. There are a lot of opaque decisions that go into designing these models. And it turns out that these decisions can radically alter the results that you get when querying these models. A third experiment had to do not with reliability and consistency, but with what the model is telling you. So as you mentioned, there is a concern that these models may not be reflecting empirical language usage. In the United States in particular, but in many other countries as well, there is a movement toward ordinary meaning, text-based interpretation. The idea is that if you ask a large language model a question, you get an answer that reflects how normal people think about language. But that's only true if the large language model is relying on its pre-training, is reflecting the enormous corpus of real text in giving its responses. But we know that models are post-trained, and post-training takes, potentially, its responses away from the pre-trained data. So I test whether the same model, pre-trained versus post-trained, will give a different result. And I did this across a few different models. And I find that although the correlations vary, the correlations can be low and at most are moderate between the pre-trained and post-trained model. So that suggests that models are not telling judges the information about ordinary language usage that judges might expect. So all of these results, they were done across a number of different questions, a number of different models, and they suggest that there's wide variability in the responses of large language models, and also that large language model outputs may not be reflecting ordinary meaning.
Thank you, John. So as a last question, I think we should still touch on the practical implications of your research. Now, since you highlight some critical vulnerabilities of those LLMs when used in legal interpretation, what are the concrete steps that we should take in order to address those concerns?
Right, so I've probably come off so far as a big AI pessimist when it comes to courts and judicial interpretation, but I think of myself as an AI optimist. And there are ways that we can fine-tune or develop structures around large language models that can improve their application to courts. So to give you some examples, you could fine-tune a large language model to imitate the decisions rendered by actual judges. And if you do that, you're not relying on an off-the-shelf language model, but you could have something that potentially regularizes the outputs of judges, prevents outlier judges, decreases the amount of noise in judging, gives more reliable outputs. That's one thing you could do, and that's something that I'm working on in separate work. You could also structure your inputs to the large language models in a different way. So you could try and extract key facts from a case and then feed them in a systematic manner to a large language model. Probably the most promising approach, and something that we're seeing in a number of countries right now, is more aggressive control of the models through human AI hybrids. So what does that mean? It means that, for example, instead of just asking a model to give the correct decision in a case, you could use the model for legal research. You could use it to extract information from a large body of documents. You could use it as an assistant rather than as a standalone AI judge. And we see judges doing this in a number of different countries. This is much less controversial. So I think there's a lot of potential for AI to improve and inform the practice of judging without trying to take over from the judge and make actual decisions.
Thank you, John, for being with us today. We look forward to your future research.
Thank you for having me. It was a pleasure talking with you.
And to our vlog viewers, we hope you enjoyed this episode as much as we did. As always, see you next time.